Hi, my name is Matthew Rose, and I'm a senior at the University of Rochester, majoring in biomedical engineering. I am here to introduce CamPak. The members of CamPak include myself, Rosie Cash, and Nathan Ward. We have partnered with Rochester Rehabilitation and NYSID through the CREATE program. Rochester Rehabilitation is unique, as it truly explores the incredible work that comes out of the Equal Opportunity Act. At Rochester Rehabilitation, individuals with both learning and anxiety disabilities have the opportunity to produce products that benefit the greater research and design community. As a team, CamPak is creating a device to increase the efficiency of packaging an underwater camera into a foil bag. The primary goal is to reduce friction on the camera, which will allow for an increase in packaging per hour, thus increasing the wage for workers. As the design stands right now, the camera packaging process starts with the cardboard shoehorn. This helps to insert a camera inside the foil bag for packaging. However, this method is both inefficient and difficult for workers. Due to the fact that the cardboard is fragile, the frequent replacements take away from efficient production. Instead of using the time to package more, workers find themselves having to replace the cardboard after just a few packages. Here, you will see the first 4 steps of the current process. The first step involves the manual opening of the foil bag. Then, the cardboard shoehorn is inserted into the bag. Once open, the camera is slid into the foil bag and the shoehorn is removed. Lastly, the foil bag is hot sealed. Our device seeks to improve efficiency in the opening of the bag and insertion of the camera. Heat sealing is a separate process and thus is untouched by our device. We predict that by reducing the friction between the camera to bag interface and controlling the orientation of camera placement, CamPak's device will increase the efficiency of the camera packaging process.
Here's how to use our device. Step 1 is to place the camera onto the device's platform and then to open the bag using the 2 immovable spindles. These act as guides, helping the operator open the bag. The second step is to slide the bag over the camera. The spindles prevent the rubberized side of the camera from coming into contact with the foil bag, making the process easier. With the foil bag situated over the camera is then pinched and pulled upwards to remove the now packaged camera from the device. The final step is to heat seal the bag using conveyor belt heat sealers. As you can see, the current system takes 18 seconds from opening the bag to heat sealing. We chose to optimize opening the bag and inserting the camera into the bag as our main focus. Our goal is to reduce the overall time. The particularly difficult steps of the current process are in opening the bag and then inserting the camera. Opening the bag is difficult because the sides of the bag tend to stick together, and inserting the camera is difficult because the rubberized camera can get stuck in the bag.
Thank you, Rosie, and welcome to Live Action. This is our current prototype. We have 2 spring steel spindles on the sides. Spring steel we use because it's very easy to bounce back to its original shape, which helps us open the bag a little easier. The front of the device is made of high tensile steel, 1/8 inch, which is very useful because it prevents the bag from flexing while we're sliding it down over the front of the camera. This device also has a base made out of wood, and we're going to drill holes in the 2 corners to allow the device to be stationary on Rochester Rehab's workstations. Now, for a quick demonstration on how our device works. You can insert the camera like this, in between the 2 spring steel rods and the 2 high tensile steel rods. Then the bag is pulled open using those front 2 high tensile steel rods, and then it's just slid down over the camera and lifted up. We've reached as low as 9.4 seconds, which is a very big improvement over Rochester Rehab's current on average 24 seconds.
Like with any transition, there requires an adjustment period. Right now, the shoehorn method is a familiar technique to the workers. However, once learned, we expect an increase in efficiency and production. It is our hope, as CamPak, that our device becomes the standard method used at Rochester Rehabilitation for the packaging of disposable cameras. We would like to thank Drs. Seidman, Lerner, and Law, our TA Catherine, and Louis Reyes at Rochester Rehab for all of their continued support and guidance. Thanks for watching!